Hi all, see this problem appeared in 2019 in the syllabus from complex number, right? So here the information given that we are having a complex number in the form of z minus alpha, z plus alpha, and it's purely imaginary. So let go ahead and consider some complex number equal to this, right? So let's go ahead and say that let omega is equal to z minus alpha, z plus alpha. Now here, right, this says that it is completely imaginary. So therefore, obviously, let us assume it as I into A, right? Completely imaginary means that it is cannot have a real part. So I just assume I and A, okay? Now let us take omega bar. That means that it will give you as z bar minus alpha divided by z bar plus alpha, and that's obviously equal to minus IA, okay? Because we are taking actually the bar, so bar will be applied overall, right? So therefore we'll get that z bar minus alpha bar divided by z plus alpha bar. Now here alpha is given as real number, so therefore it's a we cannot take that under the bar, right? So therefore it is done. Okay, now see that as it is a purely imaginary, so if we add them together we'll get it 0, right? So therefore from here we can easily understand that that's imply that omega plus omega bar is equal to 0 as omega is purely imaginary. Also, you can remember this relation. Now, let's calculate omega plus omega bar equal to 0. So, therefore, we can say that z minus alpha divided by z plus alpha plus z bar minus alpha and z bar plus alpha, that's equal to 0. Let's add them together using that normal LCM method. So z minus alpha multiplied by z bar plus alpha plus z bar minus alpha and z plus alpha, that's equal to 0. Now let's multiply that together. So therefore it's imply that z into z bar plus alpha into z minus alpha into z bar plus minus alpha square. Then we can easily write down for the next term, it is z into z bar plus alpha into z bar minus alpha into z minus alpha square, and that's equal to 0. Okay, so in alpha square there will be no bar. Actually this is a mistake. Okay, now see that we can easily get that calculation as 2 z bar alpha z and alpha z get cancelled, alpha z bar get cancelled, so therefore minus 2 alpha square, that's equal to 0. That's imply that z bar is equal to alpha square. Now what is z into z bar? That imply that it is mod of z square, that's equal to alpha square. That's imply that alpha is equal to mod of z. Now see that given that mod of z is equal to 2, so therefore for us the required values of alpha is 2. That's why obviously option D is the correct choice, and that's it. So you can easily see that we can apply that formula or the relation of a purely imaginary case, that omega plus omega bar equal to 0. Then we just go ahead with that normal calculation, arithmetic or algebraic calculation you can call, is just a multiplication. And here we use the concept that product of any complex number multiplied by its conjugate, it will gives you, okay, the modulus of that, right? That's it. So that's the problem. Hope you understood it. Thank you.